geometry. Alrighty then, let's get to it. Today we are on page 35 to 37 and we're going to be talking about perpendicular lines, and I hope you remember what perpendicular lines, but if you don't remember what they are, parallel lines are the lines that never meet. They go on and on and on forever, whereas perpendicular lines, they meet like this and they form a right angle. And here's the definition that I would like you to write in your notebook. Perpendicular lines, this is on page 36, I believe, at the top, are two lines that form right angles. So I have a picture over here of some perpendicular lines. Line DB and line AC are perpendicular because they come together and they form right angles. Angle 1 and angle 2 are right angles, and angle 3 and angle 4 are right angles. Okay, so line AC, this is how you would write perpendicular. So line AC is perpendicular to line BD. Okay, we're going to come over here. I've got some theorems to share with you. The first one is, ouch, sorry, stepped on a toy. Theorem 1-4. It says adjacent angles formed by perpendicular lines are congruent. So I put an example over here. These two angles are adjacent. Adjacent means angles that are next to each other. And it says adjacent angles formed by perpendicular lines. So if these are perpendicular, then they are congruent. So we're going to say if those two lines are perpendicular, we know that's a right angle, then these two angles are congruent. Okay? Our next theorem, theorem 1-5, says if two lines form congruent angles, then the lines are perpendicular. So I put another example over here. These two lines have two angles that are congruent. So that means that these two lines are perpendicular. If these two are congruent, they must be 90 and 90, and therefore that is perpendicular. Over here, theorem 1-6, if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. So I gave you an example here. So here's two lines, and if the exterior angles, so this one and this one, these are the exterior angles, if they are, if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. These are two acute angles, and these are two exterior angles. The exterior are perpendicular, and therefore these would be complementary. And we know that complementary angles add up to form 90 degrees. So if we call this angle 1 and that's angle 2, then we know that angle 1 plus angle 2 equals 90 degrees. Now what I would like you to do is I would like you to copy in your notebooks, so I plan to see this in class, theorems 1-4, 1-5, and 1-6, and you also have the perpendicular line definition. So go ahead and do that. All right. Over here I have a proof. Sorry, it's right here. Given BA is perpendicular to BD. So here's BA and here's BD, and I know that that means that that's perpendicular, okay? Prove angle ABC and angle CBD are complementary angles. So we have to prove ABC and CBD are complementary angles. Complementary angles are angles that equal 90 degrees when added together. Okay, so I like took every single step that I could think of here. BA and BD are perpendicular, ray BA and BD, because that was given. So then I wrote ray DB and ray BA form a right angle. That's by the definition of perpendicular lines. The measure of angle ABC and the measure of angle CBD, so this angle plus this angle equals the measure of angle ABD. And how do we know that? Angle addition postulate, okay? The measure of angle ABD, this whole angle equals 90 degrees. How do I know that? Because that's the definition of perpendicular lines, which is what I was given up here. So the measure of angle ABC plus CBD, this one plus this one, equals 90 degrees. And I said the transitive property here because if ABC plus CBD equals this, and then this, if I stick that in, that equals 90 degrees. So if I got rid of the middle section, I could just say this equals that. Remember, the transitive property is A equals B, B equals C, then A equals C. So that's the transitive property. And my last step, angle ABC and angle CBD are complementary angles. And that's the definition of complementary angles. That's a really, I tried to take as many steps as I could to try to show you different things there. All right, so the last thing I wanted to show you was this proof that was in your book. This is also on page 36. So it has this picture I drew in the congruent signs, but it says given angle 1 is congruent to angle 2, so I drew the congruent signs. Prove that angle 3 and angle 4 are complementary angles. So there's angle 3 and angle 4. We want those to equal 90 degrees because complementary angles add up to 90 degrees. This is in your book. Statement number 1 is the given. Angle 1 is congruent to angle 2. Statement number 2 says K is perpendicular to L. So K here is perpendicular to L. And the reason why I know that is because one of the theorems that I already told you, if two lines form congruent adjacent angles, which these are, then the lines are perpendicular. Okay, so that makes sense. Angle 3 and angle 4 are complementary angles, so these add up to 90 degrees. How do I know that? Because if the exterior sides of two adjacent angles are perpendicular, this side and this side are the sides, the exterior sides of these two angles that are adjacent. If those are perpendicular, then the angles are complementary. And we know that these two angles are going to add up to 90 degrees. So what I would like you to do now is I'd like you to do your classroom exercises on page 37. You're going to do numbers 1 through 10. You do have to do a proof in there. And so I want you to shut it off now, do the classroom exercises, and I'll be back on to tell you what the answers are. All right, have fun.